If you are unaware of who Nathan Oakley is, let me tell you. He is one of the most deplorable flat earthers out there. Constantly rude, pant-wettingly wrong, and one of the most insurmountable egos in existence. So when he released a video which he thinks will end the flat earth debate once and for all, I simply had to have a look. Hello all and welcome along to another video with me, Simon Dan. Thanks very much for joining me. Now, as I said in the intro, Nathan Oakley is not a very nice person. And before we get into today's video, I want to show you a quick clip from him, talking about the Flat Earth book that he is currently writing. We say writing, but there's two other people writing it and he's just going to slap his name on the front of it. But hey ho, have a look at this.
This will be the finest, the highest standard, the best, most qualified, most cited book on flat earth that there has been or probably will ever be available. It is the gold standard, and I would suggest that it will take a significant time and a significant, and even greater, more significant effort to best this book in terms of the quality it will provide any individual who chooses to read it about the nature of Earth and its flatness.
So the best flat earth book out there, hey? Well, I don't mean to be rude, but that's kind of like saying the best smelling portaloo at a festival. We'll all await that book with bated breath, I'm sure. Right, well, let's get on with the main video then, which is Nathan Oakley looking over a flat earth video. I think he thinks this is the end of the flat earth debate and that flat earth win from this. Let's have a look, shall we?
This test was conducted with respect to Pikes Peak in Colorado, which is perfect with that 6,000-foot base elevation.
Okay, so straight away, when you say 6,000-foot base elevation, that's the end of the discussion, okay? So we are 18 seconds into this video with the FBI warning, the typing sound effect, and the first line, zoom in, all the graphics. First statement, we're talking about a mountain that is measured off a flat earth. Okay? There is no other way to measure this mountain. If this mountain measurement is used, Earth is flat. Because we've measured it flat.
What an absolutely nonsensical thing to say. Apparently, elevations are measured from the Flat Earth headquarters now, right next to the big ice wall gift shop. 6,000 feet above sea level does not mean flat ground forever. It means the average level of the oceans, which, by the way, curve with Earth. That's why we call it a geode. Ever heard of that word, Nathan? When you say 6,000 feet above sea level, what you're really saying is 6,000 feet above the geode. It's the standard 0 point for altitude everywhere. So no, measuring a mountain's elevation doesn't assume the Earth is flat. It assumes the Earth has curved sea level.
For the height of a flat Earth in feet. That's what we used. That's the way to put it. Okay, so that's it. That's it. That's the end of the discussion. It's over. Okay? This is the end. There never was a discussion. So from this point forth, from this point forth, there's no reason to move forward. Right? Okay? So what we're talking about, Earth and how it gets measured flat to describe the height of the mountain.
What Nathan is trying and failing to argue here is that since elevations are measured as vertical distances from sea level, and sea level is assumed to be flat, then the whole system collapses if Earth is curved. Okay, look. Land surveyors do often use flat plane approximations over short distances, because on human scale curvature is tiny. But over longer distances those approximations break down, and that's why geodetic surveying exists. It's based on curved Earth models, always has been. Every major bridge, or tunnel, or transcontinental railway, all built assuming Earth's curve.
The test was conducted at Dr. Heffron's house, which was 50.7 kilometers or 31.5 miles east of Pikes Peak.
Okay, so we just stop it there. Now we're at 29 seconds. What we got now? Got a directionality east. It's a directionality that only exists if Earth is flat.
Does Nathan somehow think that if the Earth was curved, we shouldn't see a 6,000-foot mountain from 31.5 miles away? What's weird, of course, is that east, north, south and west are defined using Earth's rotation and axis. The misplaced confidence of Nathan here is off the charts.
Again, so to further this discussion point, we're not a discussion point here. We're already past the discussion point, as I just explained. It's over. But to go forward and pretend there's a discussion point, we're now using flat Earth directionalities and linear distance measurement in either miles or kilometres. That's what we're doing. We're taking the measurements that a flat plane can only give us in terms of the direction, and we're taking the measurements that a flat Earth only will afford us in linear miles or kilometres to suggest that there is an argument to be had, a test to be done. There's no test needed. There's no argument to have.
Linear measurements don't require flatness. Saying that miles only make sense on a flat plane is like saying rulers only work on flat floors. It's rubbish. You can measure curved surface in miles. Surveyors, engineers, pilots all account for curvature constantly. In fact, over long distances, not correcting for Earth's curvature leads to many errors. What Nathan is basically saying here is that by using miles, directions and measurements, you're secretly a flat earther. Have a day off, mate.
Here's a picture of Pikes Peak from his driveway. Pikes Peak has an elevation 2,226 meters or 7,303 feet higher than Dr. Heffron's location.
Okay, so Dr. Heffron's location is measured with respect to sea level in terms of altitude. His elevation can only and will only ever be measured off a flat Earth. Earth is measured flat for his height, measured with surveys with respect to the measured flat sea level used to measure his height from it. Earth is, again, only capable of measurement with respect to how flat it is to describe this at all.
Repeating yourself doesn't make it any more of a fact, Nathan. Now, you mentioned surveys. And yes, local land surveys use flat approximation for convenience, especially over the small distances I mentioned. But real elevation models, especially for locations many miles apart, account for curvature. Even manual levelling over long distances uses vertical datum corrections.
Further to that description of this location, we have an on-screen depiction of the flat Earth only kilometres and the flat Earth only height of the mountain in metres, and the flat Earth only elevation angle measurement of the mountain. So to summarise, on screen are 3 flat Earth only measurements.
Incorrect. Believing that to be true and it actually being true are two very different things, Nathan.
So obviously there is nothing to discuss here. Earth is flat.
Now, we're going to assume a flat Earth and use some trigonometry.
No. In order to apply trigonometry to Earth, Earth will be measured flat and is measured flat.
Trigonometry doesn't care what shape you're on. It's just relationships between angles and lengths. On a local scale where curvature is negligible, normal trigonometry gives good approximations. But on large scales, spherical trigonometry is used. You know, the one that assumes the Earth is a globe, used by pilots and astronomers and GPS systems. Flat earthers just ignore it. You can absolutely apply trigonometry on a globe. You just have to use the correct type. In the case of this diagram here, 50 kilometres is nowhere near far enough to start using spherical trigonometry. The Earth's curvature is negligible over that distance, so normal trigonometry is absolutely valid. Nathan bangs on about Earth being measured flat for another 2 minutes before going back to the video.
Peak has an elevation 2,226 meters or 7,303 feet higher than Dr. Heffron's location. Inputted the distance and Pikes Peak elevation, and you get an angle of 2.514 degrees.
Again,
Now, just to reference the actual video being played here for a second, this is basically the angular size you expect on a flat Earth. However, on a globe, some of Pikes Peak is hidden below the horizon, 137 meters to be exact at that distance, which means the angular size of Pikes Peak from that position is 2.36 degrees. There is no way that your eye is picking up a difference of 0.16 degrees. No way. So this measurement proves nothing either way. Just thought I'd throw that in.
I've already preemptively summarised the flat Earth elevation angle only capable of a degree description with respect to a flat Earth that has been measured.
Or 2 degrees, 30 minutes, 50 seconds. Dr. Heffron calculated 2 degrees, 31 minutes, so they are pretty close.
You don't calculate these degrees if you're talking about mountains in the distance with respect to their elevation angle. This is only ever a measurement, like depicted here.
You absolutely do calculate these degrees when talking about how high a mountain appears from a certain location. That's how line of sight works. Elevation angle is often measured by calculating it using height and distance, just like we did earlier. This is pure drivel, even for Nathan. And his book is going to be first class? Yeah, okay, Nathan.
This is an elevation angle measurement. So when someone suggests that they've calculated this, no, you'll measure angle representations by measuring the angle. It can only be done one way, and that's by measuring it. With respect to the flat Earth linear distance in kilometres and elevation angle only capable of acquisition from a flat surface level.
So Nathan is basically saying you can't calculate angles, only measure them, but also only on a completely flat surface. I'd love to see Nathan stand in front of a surveyor and say, nah, you're doing it all wrong, mate. You can't calculate anything, only measure. That'd be amazing viewing.
Measured angles shouldn't or should be something is a non sequitur that's beyond idiotic. Because I measure an angle to that tree is a statement about me measuring an angle to the tree in the distance. I measure an angle to this mountain is simply a measurement that is a prerequisite flat Earth measurement, as opposed to it should be 2 degrees. It should be 8 degrees. No, it shouldn't be anything. It just is what you measure it.
The angle to a mountain or a tree depends on height difference and distance, both are which measurable, predictable and calculable. If you claim the Earth to be flat, your prediction for that angle will be different than if we assume it's a globe. And you can absolutely test that. Nathan saying it just is what you measure is a way of dodging that model, because the globe model works and the flat Earth one does not.
So here we are into the dicey realms of what things should be. No, what they are measured as thus far is flat. And that is the end of the discussion, because there isn't one. If you're going to suggest there is a discussion moving forward, then please, ball believers, on your knees acknowledging the linear distance, perpendicular elevation, and flat Earth prerequisite elevation angle.
Yeah, okay. On a local scale, I will acknowledge all of that. Just a couple of points though. Measuring linear distance doesn't mean the Earth is flat. It means you're measuring the shortest path between 2 points. Over small distances, you can use straight line approximations. But over large distances, we use great circles, which only makes sense on a globe.
That will be required to have this claimed to be discussion, which it is not. Upon your sinking to your knees in acknowledgement of the flat Earth we measure, and we only measure a flat Earth, it puts an end to any suggested discussion.
Well, it doesn't really, because we don't only measure Earth flat. We measure it curved. Long distance geodetic surveying must apply spherical Earth models. High altitude bloom flights measure Earth's curvature. The properly conducted Bedford level experiment does too, as well as countless other things. Dear oh dear Nathan, this has been an awful video for you, it really has. Well, there we go, another one finished all for today. Please do let me know in the comments what you thought of Nathan's performance there. As I say, we're all done and dusted for another one. Thanks so much for watching today. It is as ever appreciated. If you enjoyed it, please do consider subscribing to the channel, hitting the thumbs up button too, and sharing as well if the feeling takes you. Thank you. I've been Simon Dan. Have yourselves a great day, and I'll see you tomorrow for our favourite demonstrable realist, Level Earth Observer. See you then.